let us understand the Bernoulli's principle in fluid flow. So while studying Bernoulli's principle, let us try to recall what is the meaning of a streamline. So here shown is a pipe through which fluid is going to flow. Now the fluid will flow in something called as a streamline. So let us say this is one streamline along which the fluid is flowing. This would be another streamline along which the fluid is flowing, and so on. These streamlines do not intersect and they are approximately parallel-ish to each other. So let us say this is a pipe, and I were to draw streamlines, then I would draw them like this. So this is one streamline, this is another streamline, this is another streamline, and so on. So close to each other, they are approximately parallel to each other. The velocity of this point of a flowing fluid is going to be tangent to the streamline at that point. So here the velocity is tangent like this. At every point the velocity is essentially tangent to the streamline. So because of that, two streamlines cannot intersect, because let us say if two streamlines were to intersect, then one streamline is going like this and another is going like this. So at the point of intersection we have a conflict, because one velocity would go in this direction and one velocity would go in this direction. Remember that any given point that is flowing in a liquid can have only one given velocity, logically speaking, and hence we do not want this conflict to happen, and hence we postulate that two streamlines cannot intersect. So while studying the Bernoulli's principle or the Bernoulli's theorem in fluid flow, we postulate that the fluid is flowing along streamlines. So given that the fluid is flowing along streamlines, let us say the fluid is flowing in such a manner. This is the way in which the fluid is flowing, and so on. So I have drawn only two streamlines. That would suffice for this question. So let us say this is the velocity v1 of the fluid. This is the velocity v2. Alright. So there is also going to be gauge pressure inside the fluid at this point. Gauge pressure is the pressure that fluid molecules exert on each other, maybe because of the weight of the fluid or because they were pushed from behind. So by Pascal's law, they will transmute the pressure that was applied on them, that will be transmitted directly. So let us say this is pressure P1, let us say this is pressure P2 at this point. Alright. So here the height of this point from the ground, this height will be h1 and this height will be h2. So I'm labeling this height as h1 and this height as h2. What does Bernoulli's theorem or Bernoulli's principle in fluid flow state? It essentially states that the three energy terms, that is force dot dx, let us say this is the work done, so this is one energy term, plus the kinetic energy half mv square, plus the potential energy mgh, potential energy with respect to the ground. Now these three terms per unit volume of the fluid, okay, so these three terms divided by volume of the fluid is going to give us a constant value. This is constant. This is the Bernoulli's theorem of fluid flow. So if we do analyze carefully, then we can write down force dot dx as, in fact here I'll choose to drop the vector notation basically because of what we are about to do. So force dot dx divided by volume. So volume I'm going to write as ADX. Okay. So here dx gets cancelled. We are left with F upon A, which is nothing but the pressure, plus half mv square divided by volume. So that is going to give me half rho v square essentially. And the third term is mgh divided by volume, so that is going to give me rho gh. So the addition of these three terms is constant. Alright, so force upon area is nothing but pressure at that point, which we have mentioned as P1 over here and P2 over here. So we are essentially applying Bernoulli's theorem at this point and this point. So the addition of P1, and then let's look at the further terms, plus half rho V square plus rho GH is going to be constant for a particular fluid that is flowing through a particular pipe. Alright, so in this question, what we can then understand is that for the position 1, I can write down P1 plus half rho V1 square plus rho G H1. So mind you, this H1 happens to be the height from the ground. So this happens to be H1 and this happens to be H2. Because this rho G H1 and rho G H2 are essentially measuring, okay, the potential energy with respect to the earth. So this and this height are measuring the potential energy with respect to the earth. So this is going to give me P2 plus half rho V2 square plus rho G H2. Alright. Many a times, this equation reduces to the following equation. Many a times, this particular term of pressure and this particular term of pressure is expressed as P naught plus some height rho G, let's say y1. Now this y1 should not be confused with this h1 basically. H1 is the height from the ground and y1 is the height of the fluid column used to measure rho gh or used to measure the pressure P. So basically this pressure P1 should not be confused with the pressure rho g h1. This is very important to understand over here. This rho g h1 is because of the potential energy that the fluid holds with respect to the ground, and this pressure P1 is simply the pressure of gauge of the fluid, or it's simply the gauge pressure that the fluid particles exert on each other basically. That is one important distinction that needs to be remembered. So many a times this equation may boil down to something like P1 is equal to P naught plus rho g, let's say y1. So this is just a method to write P1. So let us say typically this will happen if, let us say, I have an opening over here wherein I allow the liquid to rise. Let us say the liquid rises till this level, and let us say this height happens to be y1. Now if I have another opening over here and I allow the liquid to rise, and let us say the liquid rises to a height y2, let us say. Alright, so then P0 plus rho g y1 will be P1, and similarly P2 can thence be written as P0 plus rho g y2. Again I am repeating, this y1 should not be confused with this h1. This y1 is just being used to measure the pressure, nothing else. And h1 is the height from the ground, which represents the potential energy per unit volume of the fluid. So many a times this equation can be reduced to P0 plus rho g y1 plus half rho v1 square plus rho g h1 is equal to P0 plus rho g y2 plus half rho v2 square plus rho g h2. So we can say that this is the Bernoulli's equation for 2 points, and we'll be using this Bernoulli's equation at many places actually. So let me box this very important equation that we have obtained. So this is essentially nothing but the energy conservation equation per unit volume. So what does Bernoulli's equation essentially state? that for streamlined flow in a pipe, we have the summation of the total energy per unit volume to be constant. Alright.